At Clarke Colors, our focus is to try to provide and supply an expanded palette of concrete pigments. In the industry, typically used red iron oxide, yellow, and black, the four-color system that a variety of producers around the country have used for decades. Our focus is to bring a wider range of primary colors to the industry. What we're going to show here is how water wettability is very important for a variety of different types of pigments. On the left, we have our main cobalt blue 11L747, a high-performance water wettable pigment. It is a unique blue in that it can be used alone in white or gray cement. It doesn't have to be blended with black or shifted with red. It can be used alone. But what we're going to see here is that since it is a surface area of roughly 8 to 10 square meters per gram, similar to iron oxides, it is water wettable in a variety of mix designs, meaning you don't have to use it at a certain point. You can add it to your sand and dry blend. You can add it to your water. You can add it to your sand and cement. You can add it at a variety of points, just like iron oxides. So when we add it to the glass of water, you can see how it disperses and wets out completely without any agitation. And that's important for the coarser types of pigments that are used in concrete. Now when we move to the part B, this is unique. These pigments are very high performance automotive grade pigments. They are much higher surface areas than iron oxide and cobalt blues. They contain surface areas of roughly 65 to 80 square meters per gram. Just like aggregate and sand, pigment have particle size distribution and different gradations, so you have to treat them in a different way. So as we can see here, when we add the micro Part B blue, you can see that it floats on the surface. Now, the fact that it floats on the surface is due to the higher water surface tension of a typical mix design. So that's why you have to add Part A and Part B pigments at a different point. You can't add the Part B to the sand or to the aggregate or with the other blue pigments. You have to add it at a separate point. So as you can see, the container on the left has the blue stone pigment that is completely water dispersed. The container on the right, which contains the micro blue, is floating on the surface. There are techniques that can be used to allow the Part B micro pigments to be dispersed properly.